Alright guys, so here's what DJ Khalid would say, another one. So we have this example 26.3 from your book, and this is a classic example of finding equivalent capacitance of a circuit where you've got all the capacitors in some kind of combination. Either some of them are in parallel combination, some of them are in series to each other. So you've got a lot of things going on here, and all you need to find out is the equivalent capacitance. So what we are really looking for is another circuit, not another circuit, the same circuit where you can replace all these capacitances by one capacitance, or one capacitor with C equivalent as its capacitance. So I want to quickly remind you that when two capacitances are in series, or more than two are in series, that is, if you have this situation going on, C1 and C2, then C equivalent, actually it's 1 over C equivalent equals to 1 over C1 plus 1 over C2. And when you've got two or more capacitors in parallel like this, then C equivalent is given by C1 plus C2. So in parallel it's C1 plus C2, and in series it's 1 over C equivalent equals to 1 over C1 plus 1 over C2, right? So let's look at this problem. Alright, so if you look at these two guys, just 1 and 3 are capacitances of these capacitors. 1 and 3, I'm going to make 1 and 3 right here separately from the diagram. So 1 is right here, and then 3 is right here, right? So clearly these two guys are in parallel. So that means that the equivalent capacitance of this setup, only the setup of 1 and 3 being in parallel, is one capacitor whose capacitance is 4. How do I know that? Because equivalent capacitance in parallel is given by C1 plus C2. C1 in our case is 1, C2 is equal to 3. That means this is equal to 4. Okay. Now if you look at these guys, here 6 capacitor with capacitance 6 is in parallel with capacitor and capacitor with capacitance 2. That means that their combination is going to give the total, the effective capacitance to be equal to 8, right? So we've got two parallel setups here. One is with 1 and 3, and then the other one is with 6 and 2 capacitances. So these two guys, their equivalent capacitances are 4 and 8. So I'm going to make the new circuit now. So this is the circuit we have, right? And a new circuit is so if this is the circuit you have, the new circuit that we have here is this guy with 4 as its capacitance is still there, but instead of having two capacitors in parallel, we have just the equivalent capacitor whose capacitance is 4, right? That's what we saw here. And then here, instead of two capacitors in parallel, you've got only one capacitor whose capacitance is going to be 8. That's what we calculated here. And then this guy will be 8, and then you have this, right? So let's make it again. Let's copy this diagram and let's make it here, right? Now if you look at this, on the top branch, these two guys, and then these two guys, they are in series. This implies that to calculate the equivalent capacitance, you use this formula: 1 over C1, that is 4, plus 1 over C2, that is again 4. This implies that it's gonna be 2, right? And here 1 over C equivalent will be equal to 1 over C1, that is 8 plus 1 over C2, that is again 8, and this means the C equivalent will be equal to 4. So now what you have here is a circuit which is like this, where this guy has capacitance 2 and this guy has capacitance 4. So see what I'm doing here. Every time I solve a problem, every time I solve a part of the problem where I see some two capacitors, or it can happen that in another problem you can have more than two capacitors, they're in parallel or series, I replace that combination with its effective capacitance, right? So see, we started from here, it was complicated. Now look at this, we just have this. Now you do that again, because now what we have is these two capacitors and they are in parallel. So when two capacitors are in parallel, you just add them to get the effective capacitance. That means the equivalent capacitance gonna be 4C1 plus 2 equals to 8. So this is the final answer. Actually, let me write it down. Yeah, write it down here. So we just calculated the equivalent capacitance of the whole circuit, where you had 1, 2, 3, 4, 5 capacitors, actually 6 capacitors, can be replaced by equivalent capacitance of 8. Right. Alright guys, so there's a correction here. This should be 6. So the answer is that if you want to find out the equal capacitance of the circuit where there are 6 capacitors with different capacitances, and you need to replace all these capacitors with just one capacitor, and that we are calling that capacitor to be having equivalent capacitance, the capacitance values will be 6.0. Okay, so that is the final answer.